Welcome. So now we're looking at a problem where we're using IJK vector unit vectors in order to help represent, in order to represent our vector, both in terms of its magnitude and also in terms of its direction. When I first came across IJK vectors, I was pretty good at components, so I did not see the purpose of these things. It was only when we went to 3 dimensions that I began to see the tremendous advantage that this system has. To learn, you need to begin with 2 dimensions so you can visualize better. But take my word for it, this is one of the best things invented in physics. It's a really good system. So what is that system? The system is basically that you divide the universe up into an x-axis, a y-axis, and a z-axis. Positive x goes to the right, positive y goes vertically up, and positive z comes out of the page towards you. So this is a diagram which shows that. And what we do in order to make writing down vectors easier is we divide this up into units of 1 step, and we call this I. And to tell it's a unit vector, we put a little hat on top of it. And for the y-axis, we have a little unit vector, which is a j. And for the z-axis, we have a little unit vector, which is a k. Again, with little hats on, so we can tell that they're unit vectors. So we got to get used to writing vectors in terms of these components. They're components, they're just written down in IJK notation. So we get used to writing these vectors in terms of their IJK components, and then we get used to manipulating the IJK components, vectors that are written in IJK components with each other, and it becomes very straightforward. Very complicated problems become quite straightforward using this technique. So let's look at a simple example where I've shown a vector. This happens to be in the xy plane, so there's no z component here. And we'd like to write this down as a IJK component. And it really is, let's call it vector r. So I could say, well, vector r is equal to, and all I do is I say, what is its x component? And I know by now that the x component is going to be that, which is plus 4. It's from the origin to 4 in the positive direction. So that's not plus 4, it is plus 4i. So there's my first component. And then let's add the second component to it. So now I look in my y-axis and I see that my y component is there. And so that would be plus 2j. And then I know that there's nothing in the z-axis, but I don't like to leave that blank because you never know if you just forgot to write it down or whether it actually is 0. I mean, 0 is a value. It's as legitimate as 1 or 2. It's just we tend not to write down 0 because when you have nothing, why talk about it? Well, I think we should talk about it. So this would be 0k. Now, common mistake. People often say, oh, I've written all these letters. I don't need units, but this is just a vector. It still needs units. And this, if you look, is in displacement, so that would be meters. Now that's got parentheses all over the place, so it's common for people to actually simplify things. So then they would actually say 4i plus 2j plus 0k meters. That would be a common way of writing down the answer. So if I look to the side, I'm looking for 4 plus 2, 4 plus 2. So it would be C would be the correct answer. And there we have it.